Welcome back to ELM Prep Part 7, and we're going to talk a little bit about the absolute value. And we symbolize an absolute value with these two vertical lines surrounding the information inside. The absolute value of x will be equal to some positive value. In this case, it'll be whatever the x is in here, once it gets out here, will be positive x. If this is a minus 5, once it comes out, it will be the positive value of x, which is 5. This isn't the same as multiplying a negative times a negative kind of approach. Whatever's inside, once it comes out, it is positive. That's what absolute means. From a algebra or measurement basis, the absolute is used to measure the distance. Please forgive my problem here. I have a wall over here, and I'm standing 10 feet from the wall. If I measure from me to the wall, it's 10, or if I measure from the wall to me, it's 10. So in terms of our x and y in direction, I might say this is plus 10, and this is minus 10 because of the direction of the measurement. But that does not change the fact that I am 10 feet away from the wall. So in this case, we will take the absolute value of that distance. Whatever direction you want to go, the absolute is 10. The distance is 10. So the absolute has a practical application in terms of distance. Total distance between 2 points. I start at point A and I end at point B. Well, I may have wandered around, but the distance between those 2 points is the absolute distance of that. Even though I wandered getting there, the distance is the absolute distance between the two. I might use my XY plot business, find the x and the y value using Pythagorean, and then get this value here. But again, the distance between any 2 points, A and B, is the absolute value of that measurement. Whatever that measurement is, it's absolute, which means I'm not going to consider direction when I talk about distance. I went 10 miles from A to B, or it's 10 miles from my home to work. Well, do you care whether I went from work to home or from home to work when I measured that? No, it's 10 miles between point A and B. So it's the absolute of that distance. All right, that's the absolute in theoretical things. So let's look at this in terms of, if I say the absolute of x plus 3 is equal to 10. Well, right off the bat, you say, oh, that's easy. 7 plus 3 is equal to 10, and that's true. But this is absolute, so I also have to consider that this whole value, the x, might have been overall negative. So I might say, well, if that were a negative, what would it be? Minus 10 plus 3 would be a minus 7, but the absolute of minus 7, I'm sorry, I'd have to make this 13. That's what I get for not thinking ahead. Minus 13 plus 3 would be minus 10, but when I take the absolute value, it's still equal to 10. So I have two possible values for the x in this term. So when we talk about absolute problems, we're almost always talking about two possible answers that our x can be, both a positive and a negative. So how would I go about solving that in a little less cumbersome way? So we'll say the absolute of x plus 3 is equal to 13. Well, I can say x plus 3 equals 13. Subtracting 3 from both sides, I get x equals 10. Okay, so one of the values that x could be, x could equal 10. So the question is, what's the other value that it might be? Well, it's possible that this whole quantity was in fact negative. but the absolute of that negative was 13. So if I take this negative and multiply the negative to the other side, I get x plus 3 equals a negative 13. And then if I subtract 3 from both sides, I get x equals minus 16. So the other possible value for x is 16 negative. So when we're talking absolute problems, there's two possible answers. Now lots of times we have special cases where we couldn't have a negative, like negative time. That would be meaningless to us, negative time. Or negative length would be meaningless to us. I can't have a negative length. Length is length. I cannot have negative. I either have 0 or I have some positive length. So the negative might not mean anything to us in terms of our problem. But algebraically, I have two answers. So when I take these answers, I have to look at what my problem is dealing with and determine if both answers are in fact valid answers. Okay. Well, lots of times they'll do this. X plus 2 is less than 0. We'll just do that. They'll say they give you this. Well, we know this whole absolute value has to be positive, regardless of whether it's plus or negative inside. Once it comes out, it's a positive value. Well, on here I said it's less than 0. I'm implying that it is in fact negative. Well, this cannot happen. A positive cannot equal a minus, and it can't be less than 0, so it can't be negative. So there's something wrong with our problem here. I can't have my absolute be negative. So this would be an invalid problem. So right off the bat, you would say there's no solution. In other words, if my answer was total of 3 was less than 0, that's not true. 3 is not less than 0. A minus 3 would be less than 0. But if I took the absolute of minus 3, I'm back to 3 less than 0. And this is not a valid statement. So let's look at another situation of absolute. Absolute of x plus 2 is greater than 3. Well, this is possible to be a positive, and this is a positive, so it's possible it could be greater than 3. So what values are greater than 3? So if I draw my number line, here's my 3. Well, what numbers are greater than 3? Well, everything above a 3. 4, 5, 6, on up. So this whole total has to be greater than 3. So x has to be greater than 3. Well, does it have to be greater than 3? I know that this quantity has to be greater than 3. If x is equal to 1, 1 plus 2 is 3, so it wouldn't be greater than, so it would have to be a little greater than 1. So let's look at finding this. X plus 2 is greater than 3. Taking the 2 to the other side, x is greater than, sorry about that, greater than, subtracting 2 from both sides, x is greater than 1. So any x that is greater than 1 on my number line well, if it were 1.5 and I add it to 2, that would in fact be 3.5, and 3.5 would be greater than 3. Well, I also have to consider the fact that this whole quantity could be negative inside. The negative x plus 2 could be greater than 3. Now, here's where we have to be careful with this, and I will save this problem for the next section. This is a little tricky, and I'm going to double check to see if they do anything like this. They may do it in the algebra section, so we'll have to cover this situation. But I'll cover this in the next section. I will do a little more on absolute values and solving those problems. I hope this was helpful, and please come back for part 8, and we'll continue this problem. All right, have a good day.